All right, so we're going to work on some Lewis dot structures again. This time we're going to work with polyatomic ions. There's almost nothing new here from what we were doing before. All we're doing now is we're adding charges to the molecules that we've been dealing with. So why don't we start with this polyatomic ion, nitrate. Nitrate, NO3 with a 1 minus charge, okay? If we just go through the same procedure that we've been going through, I would count the valence electrons. Nitrogen has 5 valence electrons. Oxygen has 6. But we have 3 of them, so that's 18. All right, now 18 plus 5 is 23. Now, we've got this negative charge here. The reason that this molecule got a negative charge is because it's got an extra electron. So we're going to add an electron to the valence electrons that are already there. That's 24 now electrons. All right, if I draw a structure now I'm jumping in with a double bond. I just happen to know that a double bond is going to be necessary here, so let's just go with that. Okay, I have 24 electrons. I use 2, 4, 6, 8, so I'm going to use 8 electrons for bonding. That is going to be 16 electrons left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And don't forget the brackets. Don't overlook the fact that that ion, the nitrate ion, has a negative charge. You have to show that. You can't overlook that, okay? Now, that's really all there is to it. But there's one other thing that I wanted to mention here, okay? We haven't talked about resonance structures or resonance in a molecular structure. Basically, all that means is that this double bond doesn't just live in this location at this molecule. This double bond can shift over to here, and it can shift over to here, and basically in the life of this polyatomic ion, this double bond can exist at any one of these places. Okay, so I'm going to draw a resonance structure for this nitrate ion. So here we go. Let's just do this. Okay. All right. So I've got I'll start with my nitrate. Actually, I'll stop it and I'll just write everything out and I'll show you. Okay, so I just drew this structure, and now I want to show you structures showing the double bond in different places on the molecule. All right, so there it is. I drew the resonance of the resonance within this polyatomic ion nitrate. Okay, we can see that double bond is here, and then at the next moment it can be there. At the next moment it can be there. Okay, I'm drawing it in this way to show that these all do exist. They just kind of all exist at the same time. This molecular structure has resonance. How do you know that a structure is going to have resonance? Basically, you know it by, well, this. If you change the double bond to some other location, it doesn't change the structure at all. I mean, in fact, if I just took this structure and rotated it counterclockwise, you would see the double bond on top. If I kept going counterclockwise, you would then see the double bond at the bottom left. If I turned it counterclockwise one more time, you would see it where we started, okay? So these structures all exist all at the same time, basically, and that's what resonance is about. Okay, let's try another example. There's only one other example that I know of a polyatomic ion that is positively charged. So let's try a positively charged ammonium. Okay. All right, so I started with my ammonium formula, and I counted the valence electrons, and I got 9. Now, this polyatomic ion is a cation. It has a 1 positive charge, 1 plus charge. How do we get a positive charge? We get rid of an electron, okay? So I'm going to do that right now. I got rid of an electron. Now I have 8 left over. Okay, let's now draw a structure for this. All right, I just used 2, 4, 6, 8 electrons in making these bonds. So I used up the rest of my electrons. I have this structure now, and it has a 1 plus charge, and that's all there is to it. All right, so resonance is probably the big new thing here, and that is this structure. And again, resonance happens when you can move a double bond around the molecule and it doesn't change the structure. We are saying, in fact, that that double bond does, in fact, live at all other places in that molecule, okay? So there you have it. That's about all that needs to be said in this video.